Which one are you working on again, Aubrey?
Number 69, section 5.1.
Okay. So let's take a look at this one.
Because I found the vertex, but I don't know how to interpret it in a way that makes sense for what it's asking.
Oh. Wait, 5.1 number
5.1, number 69.
69. Okay. Yeah, the way they word this could be a little trippy. It sounds too encompassing, really, to a certain degree. Among all pairs of numbers whose sum is okay.
Including decimals.
You want to find the specific pair that has the largest product. Do you know what either of the two numbers is? Don't have a clue at first, right? So each of them have to get a variable name, right? Okay, so you chose two letters. You can use whatever letters you want to. Very often students will default to X and Y. You can use A and P, I don't care. So let's say if we have X and Y are my two numbers. Is everybody with me? 69 needs, the answer will be the product, but I need to find the two numbers. And then I can just multiply to get the product, right? I don't know what they are, so in algebra, what do? We give them variable names. The reason we give them math names is now we can do math to them. So how do I represent sum is 6? This is what they tell me. Sum is 6. What's that equation? Yep. That's what they tell me. What do they ask me about? Yeah, the largest product, right? Yeah, so the product function is x times y. Yes? This is just the product of the two numbers. No. What equals 6? Their sum is 6, and it wants me to find the largest product.
So from there, you could not just take all of the numbers that add up to 6 and then just multiply them?
Yeah, you could. How many numbers add to 6?
Not that many.
Well, a lot.
All right, real quick. 1 plus 5, right? 2 plus 4. 3.79, 2.21.
Okay, that's
All right. Because the answer could be, it probably isn't, but the answer could be those, what I just said. Yes? All right. So making a list or guess and check, no. You guys with me? There's a class I teach where it's Math 120, where I say, okay, algebra is one tool. You could use other tools. We are effectively in an algebra class. So even if you see the answer a different way, you have to show me algebra. Because that's the point of the class, is to learn algebra. Okay. So let me make sure you guys see this. The easiest way to break this kind of problem down, when it says find the largest blank or the smallest blank or minimize this, find this the lowest this could be. Those are extreme, like it's what's called optimization, right? Try to make it optimal. You look for what they tell you. Oh, they told me the sum is 6. Write an equation, sum is 6. And you look for what they ask you. The product is x times y. They want me to maximize this, yes? No, minimize that. I'm looking at the wrong one. No, I'm looking at the right one. Maximize this, okay. So they told me this, and they asked me about this. How can I use those together to help me? Help me.
So you could solve for one.
Yes. If you solve this for y, what do you get?
Y equals 6 minus x.
Yeah. So in this problem, what is y?
Y is
6 minus x.
It's 6 minus x, correct? And of course it is. Because if one number is 1, the other one is 6 minus 1. If one number is 3, the other number is 6 minus 3, right? So if one number is x, the other number is 6 minus x. That makes sense, yes? So anywhere in this problem, I see y, I can replace it with 6 minus x. That's what the shit y is, right? So right there I see a y. In the thing they're asking me about, which is great. So what do I get when I replace y with 6 minus x? What do you get when you multiply through?
6x squared.
What would that look like if you graphed it?
It would be a parabola
Opening
Down.
down, therefore it would have a
Maximum vertex.
maximum, yes.
So I,
Don't put Jeff's head as the answer.
so I found the vertex, and,
No, real quick, not everybody's at the same place, so.
well, I don't know how to interpret numbers.
Once you know X, you could figure out Y.
Yes, but it doesn't make sense. So I don't know if I'm doing it wrong, if I
Okay.
screw up my math somewhere.
Everybody else, if you wanna try it, keep going. What do you do now? What did we just say? This is a down parabola. Where would the maximum occur? Where would the largest occur? At the vertex. Do we have a shortcut to find the vertex? Holy shit. That was nice for once. I showed you the shortcut. Don't get used to that. It feels icky when I'm nice. What do you do? I can't see shit. Alright, you got that. That's good? Yeah.
Okay, so.
And then-
I plugged it in.
What do they want?
Well, so I know.
What do they want? Good.
And so.
Plug. Oh, that's not the product though, right? Okay, sure. I'll plug it for you. Yeah. Oh, you get weird shit. Why? No. Plug it for you. 6 times 3 is. Or even here. 3 squared is 9, negative 9 plus 18. Okay. But to be really honest, you didn't even have to use this guy, right? Because if you know what X is, you know what Y is. And if you know X and Y, you can multiply them together. That's another way to get the answer.
So when it says the largest product, it means multiplication.
Hell yeah. Sum is addition,
Yeah.
difference is subtraction,
Yeah.
product is multiplication. What's division?
Quotient.
Quotient. Right, those are the formal names, right? Like I'm Jeff, but you call me Mr. Waller, so. Addition is sum. It's like, all right. So, not surprisingly, I love these kind of problems. It's where do these parabolas show up in real life? Now, 69 is not really real life, right? Who's sitting around going, oh, this is the largest, no, who's this person? But like number 71 is real life, right? There are functions that model profits and costs and bullshit, so I want to know the maximum or the minimum, whatever, so I have to have a way to figure that out. Yeah, here's the rocket launched in the air, find the maximum height, that's a good thing to know. 75 is one I like a lot. You would, Jeff. It's not that far off from some basic calculations you do that would give you an estimate of a yield. And by the way, yield just means, like if you're talking about apple trees, it's the number of apples you get per tree, right? What do they say? It just says fruit. So if you like apples, you can make it apples. I don't know if anybody's tried number 75 out. We don't have to focus on this, by the way. This is one of many problems that will be in this test. So if you want to change the subject, that's fine.
I do have a question about, the practice test.
Yeah.
How many questions there will be?
I don't know. Normal test for me has somewhere between 20 and 30, somewhere in the 20s. Yes? And by the way, I had a teacher that said there's 4 questions on this test and they were all A through J or something. And I'm like, you teach math? So when I tell you there's like 20, 30 questions, I'm counting the A, B, C. Yes? Okay. So so which one? Which 2G.
What does it mean, graph?
Oh yeah. I don't know.
What's with the
What do you
square
mean by
brackets?
that? So this is f of x, yes?
Okay.
This is f of x.
Yep.
What would just this do? It would take that function's graph and move it how?
Invert it over the.
No, just this piece that you can see.
Move it to the left.
right? Left 2, so you move every point you can see left 2. You don't, you move the basic points, yes? Move like the top, the max and the mins and so forth. Move them back 2, and then you would flip them across the x-axis, and then you would. So the way you do this, one really good way to do this, can somebody identify a point that's on that graph?
0, 1.
0, 1, kicking ass in. So if I look at that point, how's it going to move? What did we just identify?
So left 2,
Left 2, 1, 2.
and up 1,
No,
down 1,
no.
flip it.
Flip it. Bop it. Flip it. Twist it. So it flips, and then it goes up 1. So it's going to end up right there. Find another point. Do the same shit. Find another point. Do the same stuff, right? You guys see what I'm saying? If you can identify how things are moving, you just apply those motions to the points. So what other point can you identify? What's this point?
-2,
-2, -3. So what do I do?
You move it left 2,
Back 2.
and then
Flip it. Wah!
move it up 1.
Up 1. Bam! Now at the end, can anyone tell me what letter does that look like? Ours is going to look like what letter? Because I'm flipped. So now you know the shape to put, you connect your dots. I need you to understand this. I should have put the original dot so big. Because it's really confusing, but
I think when I was looking at it on the test, I didn't make the connection between this, the G asking. I didn't think that it was.
I understand.
So,
But given that f of x graph, the result of all those transformations, yeah. I will well, I'll just say this. I will definitely ask you a question more along the lines of this one. That's a little more straightforward. So I'll probably have about 3 transformations. You identify them, and then you apply them, right? Notice I say this. What the hell does this mean?
it means whatever the function is without any of the numbers in it.
What, the function? Yeah, whatever. I was like, for a moment, I'm like, whatever the function you got there. Okay. You graph as if there was no transformation. So it's just the square root of x. You with me? You with me? Does everybody know what the square root of x looks like? A general rough shape. Can you draw it in the air for me? Square root of x. I love it. You always got that little head kick. You go. Yeah, so it goes like that. Yes? Okay. So all you need are some anchor points. Yes? Square root of x is the base function. Where does it start?
0.
0. When you plug a 0 in, you get a 0 out. When you plug a 1 in, you get a 1 out. And when you plug a 4 in, you get a... See, I'm the human in this situation, as far as you know. So I get to pick my inputs. Why did I not put a 3?
Because it's a hairy number.
Yeah, I don't know what the shit square root of 3 is. I like to pretend like I have it memorized and I always forget. I think it's 1.75 or something. I don't know. Now, here's the base function. You dot it. Because your answer should be the line, should be the result of transformations. But now you've given yourself points. Move them. What's the transformations?
Invert over the y-axis.
Reflect,
Excuse me, reflect.
y-axis,
And then move it down.
down to. So just do that with those 3 anchor points. You know the shape, move the 3 anchor points, redo the shape. Maybe? Yes?
I was on YouTube yesterday and I couldn't find yesterday's class.
Oh, I got it finally this morning.
Oh.
My camera battery died up here, and then when I got home, it didn't charge in the car for some reason. I think it jostled and came out.
Oh.
So I got home, I was so tired, I'm like, I'll just do it tomorrow.
So, can we do this and so we can see it from
What's up? Yeah, I'm recording.
Yeah.
I'm recording.
So,
Oh, you mean you want me to finish? You guys help me out then. Well, I mean, I've got the key too. I mean, so now this is very exciting for me, but I made a mistake on the key for this exact problem. So this is probably a good idea to do this together. So, real quick, is everybody cool with these?
What does the second one say?
Oh,
I'll go back up.
yeah. Far. Okay, down 2. Is everybody cool with where those came from? Could you have found those on your own? So again, you ready for this? If it's inside with the x, it's left and right. Right? So if I see an x minus 2, that means move it right 2. So if it's in with the x's left and right, because how's the x-axis move? Left and frickin' right. If it's outside, if it's not with the x, it could be put the y, it's going to go up and down. So the negative is inside with the x. A negative multiplier is a reflection. It's going to either reflect around the x-axis or around the y-axis. We just said if it's inside, it's left and right, so it's going to flip left to right, right to left. Yes? If it's inside with the x, left and right. If it's outside, up and down.
in a bracket.
So if it was a negative in front of the square root instead of inside the square root, it would flip over the x-axis, up and down. Maybe.
It's a y-intercept?
Huh?
Is it a y-intercept?
No. I mean, so this would take this and reflect it down here. Sorry. It would take every output and make it the negative of what it was. This allows for the inputs to be negative. So it would take this and reflect it back this way. If I want to stay real, what kind of number has to be inside? If I want to stay real, what kind of number has to be inside the radical? Positive, or 0, right? You with me? So my x's better be freaking negative, so that negative and negative is positive. So therefore, all my inputs have to be negative now. So that's why it just flips this way. It flips left to right, because it's in with the x, and x is all about left to right. Okay, maybe. So, take each point. If I reflect something that's on the y-axis, around the y-axis, where does it go? If you put your nose on the mirror, how far is your reflection of your nose from your nose? 0. So this stays right where it is for the first one, and then what's the second one say to do? Down 2. Bam! This one, reflect y-axis. Where is its mirror image? One over here, right? One way over this. And then I take that down 2. Bam! This one, reflect. And then I take it down 2. Bam! And then you just put the shape back on top. So that's why it's important to know the shape of a function. Right? Okay. On the key, you're going to see this. You're going to see this scratched out, which is really fun for me. Making a mistake is, it's perfect for my shirt. I wore this shirt before I realized I made a mistake, so it seems like I'm never going to stop learning. I'm never going to learn everything. It's too bad for you, John. Okay, which is good. You only stop learning if you die, so I guess I will let you. Nice and existential. The class is taking a turn. All right. I sense you guys don't like that at all. Is that a true sense that I have?
I like it.
You like it? You don't like it? So let's do a couple more examples then. See, this is today. This is the way it could be. You're like, Jeff, I did not like what we just did. Could you either not put it on the test, or can we do more examples, right? The first one's a no, hell no, so therefore the second one is a default. Huh?
You can't run from it.
Exactly. You can ask.
Yeah.
Of course you can ask. I can very quickly say no. Or yes, depending on what the question is. Okay. You guys know, we talked about this function, yes? Did we talk about this? What it looks like? Yeah. So the base function, if we do a dotted base function, I just need 3 anchor points. Right? Absolute value 1 is 1, absolute value negative 1 is 1, and so dotted line. Whee! Dotted line. Let me give us some more scale marks here. Alright, so what if I wanted to graph this? Okay, good. So we already know it's going to end up being down, right? Okay. So list the 2 transformations. Everybody sees 2, right? So if I give you this, I'm going to give you this, and I'm going to say graph the base function. If you can identify the transformations, you can take them out and see what the base function is, yes? Then you graph the base function. Okay, what are the transformations?
It's gonna go down.
No.
Down, facing.
Oh, okay. So it's going to reflect across the what axis?
X-axis.
Yeah, x-axis. Look at me. And then it's going to go up a tree. Up a tree. Yes.
I don't have those questions.
Oh. Doobie doobie doo. You also need this. You snuck in. Offensive line of chairs. So, is this part okay? If I gave you this, you would graph this, and you would give yourself some points, yes? 1, 1, 4, 2.
You can't see.
Sorry? Right? If I gave you this, you could graph this base function. Should be dotted, right? If I gave you this, you can graph this base function. Okay. Then, identify the transformations. This wants to reflect it across the x-axis. Up 3. So I'm going to take every point. If I reflect this across the x-axis, where does it go? Stays there.
Yeah.
Then I take it.
Down at 3.
What's it say?
Up 3.
Up 3.
Up tree.
1, 2, 3. Take that point. First step. Reflect it. Then
Up tree.
1, 2, 3. This point. Reflect it. 1, 2, 3. Put the shape back on. Make your point big if you miss it. And that's good enough.
That's math.
Hmm?
That's math.
I thought you said advanced math.
Oh.
Yes, that's advanced math, making your points larger.
Yep.
No matter what the function is, right? What the function? Whatever the function is, you can. These will always have the same effect, which is neat. I don't give a shit what the main function is. If I see a +3 at the end, it's going to take it up through. So later this semester, we're going to learn the function that results in a graph like this. Yes, forever, yes. The infinite octopus. And then if I have a +3 at the end, I'm going to take every point and move it up 3. If I see a -1 inside, I'm going to move every point right 1. I mean, you guys kind of see what I'm saying? It doesn't matter what the function is. I interpret the transformations the same. If I see an x -1 inside of whatever the shit the function is, I'm going to move it right 1. Why? Because every input has to be 1 bigger than it used to be. So of course it's going to shift up 1. You know, right 1, I'm sorry. How we doing? Now listen, you guys are all existing right now in this position, from my perspective, of I don't understand what the hell he just said, but I don't want to ask about it. Today's the day to that. If I say something that doesn't make sense, or if I've ever said something to you that doesn't make sense, bring it up now. I'm going to test you tomorrow. Right? But you guys should be like, all right, teacher, earn your damn money. Explain this shit to me again. Make it make sense this time. Maybe don't say it like that. But that could be like in your head as you say, could you do that again, Mr. Waller? In your head, like, make it make sense, damn it. Yeah, do you guys understand what I'm saying? I'm being silly, but this is the time to ask. If I don't ever make sense to you, I feel really bad. But hopefully, I can't possibly try to reformulate what I'm saying if I don't know you're not understanding it in the first place. Okay, so do we want to do another example of this, or do we want to change? You want one more example? Okay. What about? All right, let's see. We don't know a lot of functions yet, which is making this difficult. Let's see. How about? Yeah, there's just not a lot of functions. We don't know enough functions. All right, look. This function here. This function. How does that look? What's 1 cubed? 1 cubed is 1. What's 0 cubed? And what's negative 1 cubed? Negative 1. Yes? That's not a straight line, of course, right? What's negative 2 cubed? Negative 8, so it goes like this. You notice how it looks like a parabola that fell out? Right? It had a really bad or a really good night, so this half of it just went. Well, you can say that too. Ask your cubic function if it smells toast. Okay. So that's a base function. So how would you graph? What do you got, Jeff? I don't know, Jeff. What about? Okay, just this. What are the 2 transformations you see? Yeah, left 1. How do I know that's left 1? Because it's inside with the x, and x is left and right. And then the outside is up and down. So what's this say? Down 2. So then you take every point you gave yourself and you do those things to it. You're okay. You're fine, Bree. I'm sorry. I so often have nothing for you to do, so it was just funny. I looked at you and you're like, oh yes, I see. You're fine, Bree. I'm sorry. Oh man, I'm an asshole. All right. So then, if I take this point, I'm gonna move it. You're never gonna believe this. Move left 1, down 2. Left 1, down 1. Give yourself. Oh, my scale sucks. It's too bad. 2. Move this one. Left 1, down 2. Move this one. Left 1, down 2. And then you just put the shape back on it, and there you go. Is my pen just now running out? No. Damien!
It is I. Have no fear, because I am here.
Alright, Mighty Mouse. Yes?
Can we do some pairing factoring problems?
Sure. Alright, did that help at all? The more functions we know the shape of, the more sense it makes to do a ton of these. So I'm not going to give you a ton of these yet. Alright, so when you say hairy factoring, okay.
Well, like the 4D on the test, practice test, I want to know if I got it right.
4
But something like that, you know.
4D chess. Okay. Jeff. at, and you guys have survived through worse things than this. So the way to look at this is every term. How many terms are in that expression? 2. Each term has a number. Each term has a number of a's, and each term has a number of x minus 1's. Neither term has any x's. The more you understand what I just said, the more you understand math. They both have x minus 1's. Isn't x minus 1 an entirely different number than x? Like 6 is an entirely different number from 7. 7 don't have no 6 in it, yes? Even though it's 6 plus 1. Okay. This is all about factors, correct? You guys all with me? So the more you can see, neither one of those things has an x. So you can't take any number of x's out. That wouldn't make any sense because they don't have any x's. They have x minus 1's. So you look at the numbers first. You just go step by step. What number can come out of both 9 and 12? That's insane. It's also right. Another tree. How many A's can come out? 2, because you're the almost fair tax man. You'll take everything somebody has, but not more. Right? Can't take more than 2 from this guy. This guy can give more, you're like, whatever. Okay. And then how many x minus 1's can he take? 2. Because again, he could give 3, but he can only give 2, so you only take 2. Now I try to push this to the side of it, because now this term's result goes here. You had 9, you divided 3 out, so you have 3. You had 2 A's, you took them. You had 2 x minus 1's, you took them. Plus 12 divided by 3, 4. You had 5 A's, you took 2, so you got true. You had 3 x minus 1's, you took 2 of them, so you have 1 left. And then the last thing you can do is not really factoring, you just clean up the inside, just distribute. Even though you're not going to get any like terms, you still do it.
So if we, so you want us to distribute?
Yeah.
I thought you said that factoring was taking things apart though.
It totally is.
So why distribute?
There's nothing else to take apart. So all we do is clean the inside of this up. What we're really doing is trying, if there's anything that's like terms in there, so if I distribute, I can say, oh, there's no like terms. But if this was just a 4, and I distributed, then the 3 and the negative 4 could go together, which would simplify the inside. So it's still trying to simplify, which is the inside of it though. The factoring is done. Now we're just trying to make the insides look the best they can. This guy looks really good. Look at him. Aw. This guy needed some help. That's as much as we can do. Yes?
So then is that thing in the brackets part of the x minus 1 squared? Like, or is it just its own, like, what do you, in relation to the 3a squared?
So if I take this and distribute it, I'll get back to here.
Okay.
That's all that is. So, yes?
Can I take a stab at what you're asking?
Yeah.
So I think what he's asking is why would you write it with no parentheses and then a bracket? Does that mean the same thing?
Oh wait,
as
is your concern about the
parentheses?
brackets?
Yeah.
Oh,
That means the same thing as
I'm sorry.
parentheses.
part of my brain kicked in, and since I had parentheses on the inside, I used brackets on the outside.
It's just not identified.
So it's like, we can use squigglies, and then brackets, and then parentheses. It just makes it easier to tell
It's
what
just
part
for
goes
us, like,
with
to
what.
differentiate.
Yeah.
It's not.
It's not a damn thing wrong if you put parentheses here. Was that really your question?
Yes.
I totally didn't get that.
But you would want to
I
put
said it
parentheses
weirdly.
around both
You did.
terms, right?
Oh, I see. Now I'm thinking back. I was thinking, why does this go with this? And I'm like,
No, yeah.
I was like, I don't know what the hell this guy's saying. But yeah, the parentheses are finals.
Okay.
Yes.
Would you need to put parentheses around the other one also to indicate that it's multiplying the entire thing?
What other one?
Like the
I already have parentheses around this guy.
Yeah, but would you need parentheses around the 3a squared?
Nope.
Why?
Uh,
Because it's one term,
how do you factor? How do you factor 9?
3 and 3?
Couldn't you write 3 as 2 plus 1?
Yes.
Do I need parentheses around the 3? Oh, sorry. Do I need these? Nope. Okay.
So you're
This
saying,
is already together. If I took these away, it would not be the same thing. This would be x minus 1 squared. It's supposed to be x minus 1 squared, right? Okay. Taking those parentheses away changes the idea. putting parentheses here doesn't do shit.
Well, I meant around the entire thing.
Oh, around this whole thing?
Yeah.
Oh, that doesn't do shit either. No, I'm sorry, I'm saying it really.
No, you're not.
But I'm just saying it doesn't do anything for you. If I put these in here, nothing's changed.
No, but it's just
But if I take these out, it's a completely different problem.
because you've got multiple.
If I put 3a squared x minus 1 squared and I take those away, now it actually sort of doesn't make sense, but it looks like this is one thing, right? So if I take these away, I'm just so zoomed in. If I take these away, now it looks like this is one thing, plus this minus what it's supposed to be, this shit times this. So that those parentheses have to be there. If you did put parentheses on the whole thing, it wouldn't be wrong. Yeah.
Just extra.
Just math people, we would twinge a little bit because we don't like writing more than we have to. In my case, it's because I can't do it well. So you won't be writing less. Thank you for agreeing so quickly. No, you're fine. All right.
Safest thing is to nod and smile.
So, if we could do another example like this, if you want, right? I mean, I think part of. Okay, so number one is a lot of you guys probably don't know where to start asking questions. That could be true. Number two, you don't know how tonight's supposed to be, and you don't really trust me when I say you can ask any damn thing you want to. Math related would be good. Preferable, in fact, please do. Okay. Do you guys understand? So if anybody wanted to do another example like this, I could make some shit up. We could do it. That's what I do. I'm a teacher. I got so many problems. I don't want to share them.
Can we do some complete the square?
Yeah. All right. You want to do one where like putting something into vertex form, or do you want to do one where we're solving an equation? It's up to you. You have to know how to do both.
Let's do both.
So okay. I like that. So let's do one. The first one we'll do is put it into vertex form. Sure. Okay. Putting in the vertex form is a little worse because you don't have two sides to work with, really. Right? Everything's on this side. That's just the f. That's just the function. Does anyone remember the first thing I have to do? So my goal, when I say put it in the vertex form, what is vertex form? I'll get it started.
Parentheses x minus h squared plus k.
Cool. So I want this sucker moved over a bit. I want to do what with this?
Get it out of there.
Yeah, factor it out, make some room. So shove things that way instead of that way. Okay. Let me stop for a minute. That's your first step. Make room in. Take any number out here. Take it out. Make some room in here. This guy just stays outside. He's going to be a part of the K dude. See that? We already know what A is. What does that tell me? The fact that this is 3. It goes up, and it goes up pretty quickly, so it's going to be kind of skinny. Okay.
Sorry.
Oh my God. First thing I thought of was this. Anyway, scene from Harry Potter. He claps and the phoenix comes over. Sorry. How do I find what goes here?
It's a little one coming out.
So what I want you to realize is, when you get that 3 out there, you shove that guy over, you completely change your perspective. Now it's just, oh, I want to figure out okay, I got to do the 2 steps. 2 steps. So then the first step, of course, like you said, is the negative 4.5, and then I take that number and I square. What goes here?
Plus 4.
Oh.
I said no. So what did I actually just do? I didn't add 4. I should not subtract 4. I actually added 12, so I better
Subtract 4.
subtract 12.
Oh.
You see what I mean? We didn't just add 4.
I
Just
see.
the same way
Okay,
this is
but-
not negative 4x, this is negative 12x. This is not 4, this is 12.
Yeah.
So we better subtract that 12 we added. I really want that to make nothing but sense. If I multiply this back out, I just added a plus 12 term, so I better do a minus 12 term.
That's right.
Thank you. And then how does this factor here, this guy?
X minus 2.
And you get out here,
Minus
14? Okay, all right. I feel like I did that a little quick, but if you do enough of these, it's basically the same thing every time.
So we're always gonna multiply the number in front of the x squared by whatever we get.
Yeah.
Okay.
Because real quick, you would never do what I'm about to do. There would be no reason, but let me show you. If I were to right now, when we did this, if I were to multiply this out, I would get 3x squared minus 12x plus 12 minus 2 before I did that, right? So how did we change the problem? How did we change the original problem? I added 12. There's a 12 there that wasn't there before, so I better subtract 12 to make it the same. Now, don't freaking multiply this shit out because that's going backwards from what we need. Just say, oh, I just did 3 times 4, I just did 12, I better subtract what I just did. Right? Like we saw last night, if this is a negative, you gotta take that into account. So you'll actually be adding something to counteract that, yes? Okay. By the way, I want you to understand, this is not like basic math. This is beyond that. So it's okay if you're having a little trouble with this. It's not automatically obvious. Can anyone tell me what the vertex is now?
2 negative 14.
2 negative 14. You took way too long to tell me. No, I'm joking. Sorry.
All right.
Can anyone tell me what the y-intercept is? Very quick.
Negative 2.
I'm still waiting for the answer.
0, negative 2.
There it is. Okay. Yes, sir.
Why wouldn't the vertex be negative 2, negative 14?
Because what would the shift be? Vertex always starts at 0, 0 for a parabola, right? What are the shifts? What are the transformations? Right, 2? Yeah, because it's x minus h. So what's h? 2.
Okay.
Plus k. So what's k? Negative 14. And again, it's just transformations. Parabola normally 0, 0. Vertex. Right 2 down 14. So of course it's 2, negative 14. Right? So it's literally just transformations that lead you to the new vertex. Right? Okay. By the way, I don't think the notebook actually talks about transformations. That's something I added in, because to me it doesn't make any sense to talk about this if you don't know what transformations are. And you're all like, yeah, Jim, we're so happy you added that shit in.
I actually am.
Oh, thank you. Okay. And the other thing would be something like, let's get something a little grosser, I like it. So if I said, because you know, solve completing the square. Okay. Solve using completing the square. What would you do first?
Minus
Now I
7.
have 2 sides, correct?
Yeah, subtract 7.
Subtract 7. Get this thing the hell out the way. Get out of here. Get out the way.
And 7.
Damn straight.
And 7.
Damn. So what's the first step now?
That's right, 7. Half of negative 11. Yeah.
Right? Now listen. Does anyone, when some of you guys saw where this is going, were you like, if you put that on the test, I'm just going to pretend I didn't see it? Yeah?
Oh, there was a backside.
What's that?
Oh,
There was a backside over here.
Oh, no. Oh, shit. Oh, more stuff.
oh no.
So first step,
Oh, no.
cut negative 11 in half. Don't freaking make it a decimal.
We
Don't.
just leave it like that?
Yeah, please do. And then I do what with this?
Square.
Squirt. What do you get when you squirt?
You get that?
I did decimals. I did decimals when I did it.
Uh-oh.
You get that right there.
What's 11 times 11?
121.
121. What's 11 times 11 times 11? 1331. 1331. 121. Holy shit, mind blown. Okay.
Wait,
Somebody do it for me. Who's got a calculator? Who's got a calculator?
What?
What was the question?
11 times 11 times 11. I did, just to show you. What is it?
1,331?
1331?
Yeah.
Now do it times 11 again.
So, to the power of 4?
Yeah.
14,641.
Yeah, 14641. Remember Pascal's triangle?
Oh, yeah.
The what?
Because Pascal's triangle, 1, 1, 1, 1, 1, 2, 1.
Yeah.
Because we talked about Pascal's triangle, didn't we?
No,
Oh shit, I'm sorry.
we just know what it is.
Yeah.
Damn it.
I don't.
Oh,
I put my book on.
This year?
yeah.
Did we talk about it?
Not in this class.
I'm sorry. Real quick. Some of you guys have seen this before?
I know.
So this was less exciting, I'm sorry. Even with this, it's not really exciting, it's not the right word, but do you guys see how this is built? Just real quick side note, I'm really sorry, but see how there's ones on the outside? 2 came from 1 plus 1, 3 came from 1 plus 2. Can you tell me what the next line would be? 1's on the outside? 4, 6, 4, 1, right? Which is 11 to the 4th power. Now real quick, can anyone do x plus 1 squared quickly? Have you done enough of this? X squared plus 2x plus, what are the coefficients?
Crazy.
If you do x plus 1 cubed, guess what you get? You get x cubed plus 3x squared plus 3x plus 1. 1, 3, 3, 1. Yes? It's called the binomial theorem, and this is Pascal's triangle. Because Blaise Pascal was probably bored to shit, and he just played with this and went, holy shit.
He's probably so incredibly high.
That is actually more true than you think. It's sort of like poetry. A lot of good poetry came because of yes. Oh. We gotta finish this. All right, we will next. Okay. I'm really sorry about that aside, but this is semi-neat.
No, that's awesome.
Do you understand that if I had to do x plus 1 to the 10th, I could just kind of keep going on the triangle and then get the coefficients? Yes? Okay, that's the power of that. I hope I didn't offend her. Did you have to leave her? Okay.
Could have said
I'm not
5.
sure.
No.
She did
to me.
Wow.
She got the important person. Okay. I know where I'm right now. So 11 squared is 121 divided by. So what does this number tell me?
121.
Because
Put it where?
you added
Seven.
negative.
If I add it to this side, better add it to this side. So the trick is, I have 2 sides. I can do the same thing to both sides. When I don't have 2 sides, whatever I did, I have to undo. If I'm all on the same side, whatever I did, I have to undo. If I have 2 sides to play with, I just do the same thing to both sides. Thank you.
What do you mean 2 sides?
2 sides of an equation.
Oh.
This is a function definition. I don't really have 2 sides.
Okay.
How do you factor this? Don't overthink it. Always. I don't care how ugly these numbers get. Do you understand how brute force is what's needed here? Brute force, put whatever that is over 2. Reduce it if you can. Brute force, square the damn thing. Shove it in there, shove it over there. The first thing you wrote down tells you how to factor it. You guys with me? You guys understand? That doesn't make the numbers look any better, but when you realize how little you have to do with them, the most you have to do with them is what we're about to do right now. What do I have to do on this side?
Combine them.
So I better multiply by
Valid.
valid.
93.
So 121 minus 28.
93.
Good. 93. 90. True.
93. That's awesome. I love that you adopted my way of
And then I do what to both sides? Yeah, the whole purpose of this whole thing is to get a square out there so I can kill it. Ah! Now, if I do this, what do I put?
Plus minus.
Plus or minus? Now, doesn't this look heinous? In fact, what's the square root of 4? 2. Okay. But I don't care how heinous it looks. I'm one more step. Heinous. Yes.
No, he has. You can just do that.
Yeah. Yes.
So you can square root the bottom but not square root the top?
Of course you can.
Okay.
Since.
Now, real quick. If I said, what is 7 over 2 squared? Isn't that 7 over 4?
Yes.
You can simplify each of these separate from the other, correct?
Yeah, but you
If-
didn't do that, you just put 7 over.
But on the top, they were combined, they were together.
You ready? Square root of 93 over 4 is the square root of 93 divided by the square root of 4.
Right.
Real quick, what is 2 times 3?
6?
6. What's half of 2 times half of 3?
Half of 2 times 3 is 3.
No, half of 2 times half of 3
Half
is
of
half of
6.
6. So the square root of 2 times the square root of 3 is the square root of 6.
Right.
You can only multiply things together if they have the same root.
Right.
That's why we can do 7 times 8, because they both have the same root. None. Right? So if I have the square root of something over something, I could break it up as the square root of the top divided by the square root of the bottom. And then you can simplify, just like 7 over 2 squared. The bottom I can simplify, the top I can't do shit with. Square root of 93 I can't do shit with, square root of 4 is freaking 2.
So I can do 6 times 7.
Oh,
Is that okay?
I was getting confused.
You're good.
I thought the whole thing was.
The whole thing was under a square root, and I can split it up.
Okay.
What am I taking the square root of? The bottom and the top. Yes?
Mm-hmm.
So I can just break it up, the bottom and the top.
Oh, I see.
I like how I keep saying bottom pointing to the top, but I'll be right. Top, bottom, left, right. Okay. Last step is?
Versus?
Last step is? Add 11 halves. And as ugly as it is, I'm done, so I don't care.
That's awesome.
Clap.
Sorry.
Would you want the answer simple?
That's the anti-Jeb Bush. Clap, please. What?
Would you want the answer sort of combined to x equals 11 plus or minus square root of 90?
You can do that if you want to.
Doesn't matter.
Yeah, you can leave your friends behind. Yes. If you
Could
advance.
Could I do x equals 11 over 2 plus 90 plus the square root of 93 over 2?
Comma.
Two answers?
So you would have 11 halves plus blah and 11 halves minus blah.
Yeah.
Yeah, you can if you want to. I don't know why you want to, but you can. So if you like to visually see both answers, I understand. You can do that. So there's the 2 situations we've seen where we can use continue the square. Vertex form, solving an equation. Now, of course, what's the shortcut to completing the square? To solve an equation? No, that's the shortcut to find the vertex.